So today I wanted to introduce a little bit the Signalwire for what concerns the developer APIs. And so I'll go through the architecture very high level. And I will focus a little bit more on the developer API interfaces, and in particular on SWML, which is the programmable language that you can use to build your application. And I will do a demo, which seems a little dangerous, maybe. We'll see. So as Daniel mentioned, I've been in this industry for some time now. I'm leading a team in Signalwire to improve and expand the developer APIs. And hopefully you will see improvements in that area. Last year, I presented something at very different abstraction level, focused on troubleshooting media negotiation on WebRTC calls. So, as you probably know, Signalwire is built on top of FreeSWITCH, which is the media engine and is managing most of the media interaction and processing, including an AI kernel. Kamailio is a key component. It works at the edges. We use also Kemi and Lua, and it is, in fact, very, very cool, and we can do a lot of stuff with it. And coupled with RTP engine for some cases, Coturn for managing the WebRTC clients, and Hepic, we use it internally for troubleshooting. So this morning I saw that finally we got the new release out that probably people was expecting. So please check it out. That's a lot of work that went into this release from the core team and the community. Mostly security and stability. There was a large cleanup of the code, eliminating many modules that were basically not actively maintained, and so to clean up and make it more lightweight. And there was Debian 13 support and other improvements in the platform and tool chain. So the idea that was behind Signalwire, in particular, if you consider maybe some more critical cases like the very popular currently for AI, was that eventually, once you build your application and you're assembling different stacks from different providers, you're going to have most probably maybe some advantages, some practical advantages, but in terms of flexibility, but you will encounter most probably some problems in terms of state fragmentation, different types of errors, dashboards to integrate, and potentially, and this can be discussed and measured, a final impact on the latency on responses, depending on the scenario. The idea behind Signalwire that had the AI modules added obviously more recently was that everything is native, and so eventually everything that is also very key specific to AI interaction, like the barging and the turn taking, is not delegated outside to an LLM, but it's managed directly inside FreeSWITCH, which makes it much more efficient, and also includes also payments that were added recently. So if you imagine the media engine based on FreeSWITCH and the other components, and that it's globally distributed on multiple regions, and then the different developer interfaces, there are 10 different SDKs, or better, SDK in 10 different languages. There is a declarative programming language, SWML, a REST API, webhooks for getting events, where it's just one way of getting events, and what's called the call fabric addressing, which is just a way of abstracting resources inside the Signalwire platform, giving them an address that doesn't have a specific transport or type associated to it. It's more like the Signalwire's responsibility to resolve that address and adapt it to whatever it's meaning in that specific moment. It could be a SIP endpoint, a WebRTC endpoint, or even something different, like it could just be the address of a script that needs to be executed. And so the control plane has the main role of interfacing these two worlds, and in particular have a good ownership of the state so that it's consistent across different use cases. So in terms of interfaces, of course there's signaling, there's the REST API over HTTPS, there's the so-called Relay protocol, which uses server-side SDKs that connect over WebSocket, and then they have a bidirectional communication with the system. They can send command, receive states, updates in real time, or even commands from the platform. The WebRTC client over WebSocket again with a proprietary protocol that anyway is abstracted by the SDK, and of course SIP over different transport. For media, obviously RTP and SRTP and DTLS SRTP for WebRTC, and when needed, there's NAT traversal with Turn. And in addition to this, there's also the ability to just connect raw, to connect WebSocket and just make raw audio flow in both directions. And this is also a way how somebody could bring their own AI, because once they have the ability to connect a stream to their whatever implementation of AI they have, then the interaction with the system is just connecting one WebSocket to it and exchange audio. Then events are either provided through webhooks that can be also signed, or they can just be real-time events over the WebSocket when connected. So the REST API provides a way to basically manage all the resources. It's what you have in the dashboard. It's also exposed in the API. So you can create the resources. You can exercise the scripts. We recently added a way by which, with a REST API request, you can just run a script without having any actual call active. So whatever the script will do, which may be even creating a call or calling another script, happens through the REST API without the need for you to call from PSTN or from SIP. And there is a reference to the REST APIs, which are quite large. So you can do the usual things that you can imagine: calling, queuing, recordings, conferences. There's also video, of course. Then you can manage your own numbers. You can set up your own SIP gateways, write and manage your programmable scripts and AI agents. So these are the ways you interact with the system and you build your service. There's the SWML, which we'll see a couple of examples of later, which is just declarative language. You can write it in JSON or YAML. You can have static scripts or dynamic. So dynamic would be you get a request for an incoming call from Signalwire, and your business logics just generate on the fly the SWML script with the programmable logic depending on all the metadata that you receive. You can have a server-side SDK, which we call the Relay SDK, It just connects over WebSocket and exchanges commands and events in real time. So again, say there is an inbound call, you get an event to the client using the SDK, and then whatever logic is needed, depending on the from number and the time of the day, and whatever you can imagine. There is a WebRTC SDK, which, by the way, there will be a new version, which is now almost ready with many improvements. There is already one version out, but there will be a much better version soon for managing WebRTC calls. And then this is more like, the call fabric is more like a concept of abstracting resources through generic addresses. And of course, if needed, you can use the AI agents that are available, which are, by the way, you can completely define them with SWML. So it's just, you can use SWML to program your AI agent. So this is an example, super simple. You just define what needs to happen. Again, the SWML script could be static or dynamic. You decide. You can serve it, or we can also serve it from our platform. There are more than 50 methods. You can imagine what they are. It's like imagining your dial plan just defined in this sort of declarative way. And there's some documentation for who wants to go directly there. So beyond just calls, there are very interesting features. Of course, conferencing and queuing, which are the basic for the many contact center scenarios. There's the AI method for defining AI agents, and other interesting things like live transcriptions, which is quite cool. And as mentioned, we also have payments that can just be processed directly on the system. And a little bit of controlling the calls, or in general, the processing branching, like with conditionals and managing the state of the system with variables and conditional actions. Like, for example, typical if-then-else system, this is simplified, and it's YAML, but you get a call in, or you exercise in this case, no, you get a call in, you answer, you get the time of the day, you make a decision, and then you behave differently depending on the time. You just say something, and then you put the caller in a queue, or you record a message. Also, something powerful, you can perform requests directly from the scripts. So like in this case, you provide a URL with a body that is filled with metadata from the call itself. You perform the request, and then based on the result, you can have conditional behavior. You can make a decision depending on the HTTP request response. And then it's, as you can imagine, so you can play something, you can connect to a SIP endpoint, or move to a queue, or or a default behavior, which is quite powerful. And again, this can be either static or can be dynamic. So it's up to the developer to decide. Also, maybe interesting to see prompts. So very simple way to gather digits from the call that's connected, and again, conditional behavior depending on the real-time input. So that was SWML, which is the declarative way of defining the programming language. Then on the server side, you can have the You can use the Relay SDK. Again, it connects through the WebSocket, bidirectional communication, and you can use the same methods. It's just whatever technology or programming language you're using on your server side, you will have it available from the SDKs. And again, you will get real-time events directly pushed to the WebSocket you are connected to. Call Fabric, as I mentioned, I mentioned this because maybe it's a concept that is worth explaining in case it's in the some parts of the documentation. It's just a way of abstracting the resources. So as a developer, you don't need to worry whether something is a SIP endpoint or a WebRTC endpoint or, say, an AI agent or even a script. You can associate a generic address to the resource, and then that address can be used in different parts of the system. It could be inside a script. There could be a script that connects to another script. So it becomes very, very powerful for building whatever you need to build. Briefly, even if it's not the core of this presentation, there's you can define your own AI agents. The promise that the system is doing is that due to the native support for Bargin echo management and the turn taking, that happens directly in FreeSWITCH and it's not delegated outside. The aim is to get a much better overall latency. And so to prove it and to share the results, Tony recently open sourced this code for checking the latency. So you can just put there the recordings and it does an analysis, and you can do comparisons about different implementations. So all these, you can see how you can compose all these layers and all these different ways of interacting with the system, depending on whatever you need to do. With SWML, you can define your, let's call them advanced dial plans. You can manage inbound IVRs and escalate to an AI agent if needed. With Relay, you can have your programmable contact centers. If you are, which probably most of you are, if you already have a SIP platform, you can just connect it to Signalwire. You can send the calls in, addressed to specific CPRIs that are associated to SWML script. So you will have your programmable logic executed on the fly when you connect. And with the REST API, you can manage from the server side, you can manage your numbers, your addresses, you can inject your programmable scripts and define your addresses. And the idea is that all these can be done very quickly. It doesn't need a big interconnection process for getting there, thanks mainly to the REST APIs. So in terms of demo, it's going to be something very trivial. I'll just expose a SWML script from my laptop, and then I'll call a SIP endpoint associated to it, and I will have it executed, and then I'll change it in real time and see that that it's just changed, and I can use with the new logic. It's going to be super simple, just some Python script that generates JSON. So let's see. Okay, so say I have my Python. So this is This is the Python code. You can just run it. I have ngrok already running here. Just let me test it quickly. Okay, which is working. And then I have in another tab, I have just, we will see a little bit of metadata from the ngrok debugging interface. And this is where, so this is where I'll define the behavior for my application in the dashboard. This can be done programmatically, just it's easier now for this demo to do it manually. And this is where I set up the external SWML script that will be called when that SIP domain is actually called. So let's see if it works and if you can hear it. No. Okay, so maybe this is a candidate for dangerous demos. Because I got banned yesterday. So the source IP that I was using was banned by Kamailio because I made too many authentication failures. So let me see if I can solve it in real time. Otherwise, I don't think so, though. Actually, let me see. This is running. This is running. This is working. 5899. No, okay. Oh, I see the error. I should copy this one. And ngrok changed my address. So I save it, I change it in real time. I call again.
Kamailio World 2026. Java, you are connected to a Python handler running on a laptop.
Right, so this was a very dry and a message automatically responded from the script. Then if I go again in the script, say I edit it, and I do a minimalistic AI agent. So this is all it takes to have a default AI agent available. It's I don't know if it's very visible, but let's say it's so it's the AI method and then the super simple prompt. You can imagine you can define whatever complex behavior you want. Plus there are all the options that you can set, like the timeout for waiting for voice activity detection. And all the other settings. So assuming there are no syntax error, I change it, I run it. Just let me double check. Okay, and then I call again.
Hello, Giacomo. How can I assist you today?
And this is the AI agent connected already. And that's all I wanted to show. Then if I go back to the presentation, just for the takeaway, so I mentioned what's behind the media engine, globally distributed FreeSWITCH with AI kernel inside and Kamailio, plus the control plane that exposes interfaces for development, aggregation of state and policy and protocol normalization in one single place, and a bunch of SDKs available for the developers. Just mentioning ClueCon that will be in August 10 to 14 this year, so everybody here is invited. And that's all from me.
Okay, thank you, Giacomo. I have a first question here.
Thank you for the session. So most of the existing FreeSWITCH based contact centers has already evolved into a AI-driven workflows, right? So they internally creates a graph representation of the flow, and it creates a JSON document, and that gets executed in the FreeSWITCH as an ESL application. What prompted Signalwire to create something like SWML, which the existing UI-driven systems are not able to solve, or what operational difficulties that prompted you to create something like SWML?
Yeah, I think mainly I would say the ability to abstract and have something defined in a way with a syntax that is not really connected to the internals of FreeSWITCH. So it's in theory users, and in fact it also happens. There are users of Signalwire that have no experience with FreeSWITCH, and that was the main objective. And of course, I've shown just very rudimentary scripts where you can imagine for each of them, for each method, you can define your webhook URLs. So then you get the state in a specific format, and you can do whatever you want to do with it. Something that I wanted to show very quickly here, the ngrok debugging tool. So this is the metadata that was received by my server when I got the call. And so you can see all this metadata is available through variables to the script, and then can be used to execute. It's
Okay.
not related to your question, but I remembered.
It's Surenda. Quick question, hopefully, because we're a bit late.
Yeah. So thanks for the demo, and I really love the way it's being creating AI agent and connecting with voice. So I just want to know, does it support knowledge base or integration with vector DB? Probably like I can integrate with multiple tools here with SWML.
Okay, I'm not sure I got the question, but did you ask about integrating with other LLMs?
Okay, I'm asking about integrating with the knowledge base, RAG.
Ah.
Okay.
Okay.
Do you support with current SWML with integration with like particular knowledge base or particular vector DB? So suppose like there is a prompt is written, and once I detect the intent, I want to like take certain actions using tools, or might be using like my knowledge base stuff.
I'm not sure. I would need to. Maybe we can discuss later. I'm not sure I got the question. Sorry.
Okay. Thank you, Giacomo. I really appreciated your update. And I saw